video. And here is to try to write everything down, but uh, either way, here is our task. The null sets operator is on a mission to eradicate all lemniscates from its polar plane. This is called the polar plane. So it's not your typical XY plane, which we talked about last week, where you would move, we call this rectangular coordinates, where you would move to the right or left first and then up and down first, second. So if I graph a point, it looks like a rectangle. This is the polar plane, of which it says here, our points are now r theta, where r is the distance from mission control headquarters, which in this problem they don't really tell you. Mission control headquarters in this case here would be the origin, like so. Okay. And oh, there's a highlighter option. Let's do this. Wow. It looks like crap, but whatever. Is there a way to make it not that wide? Oh, cool. Hey, look at that. R is the distance from mission control headquarters. In other words, the distance from the origin. And theta is the angle of rotation clockwise from due east. Essentially, the angle represents rotating clockwise from standard position. They say due east, but standard that basically means rotating this way of how much we rotate. So, for example, the lemniscate located at point P on the radar screen shown at right is 4/7 pi 6. This is that point right there. These rings basically represent a unit away from the units from the origin. So we have one. I don't know if you could see this. Let me use this. We have 1, 2, 3, 4. Hence, this point P is 4 units away from the origin, and it's at the position of 7 pi over 6, if you remember your unit circle. Starting at 0 radians, it rotates counterclockwise all the way to 7 pi over 6. So it'd be better, like I said in my last lesson, this is best used if I was positioning myself in a classroom. And what I'm going to do is first face east, just so that's ways east or facing to the right. Then I'd spin and rotate counterclockwise until until I've rotated 7 pi over 6, which is 210 degrees. And then I would walk forward 4 steps, 1, 2, 3, 4. If it was -4, I would still rotate all the way to 7 pi over 6, but I walk backwards 1, 2, 3, 4. And we'll get to that more in detail. So if you had copied this down, what I was going to do is I would originally make students copy this down on their paper and then try to graph as many of these points as possible and label it accordingly. What you could do is freeze the paper or freeze the video and try to figure out the location of each lemniscate the best you can, labeling it with the appropriate letter. Do that now if you are participating. Otherwise, we're just going to do A through J. Rotating pi over 4 and walking forward 3 units. B. Remember, negative degrees or negative radians. This is clockwise. So now we're rotating clockwise to negative pi over 6, but still walking forward. So rotate counter clockwise. And this is walk forward or move forward. C 1/2 pi over 3. Um 1/2 pi over 3. That's C. D -3 pi over 4. So pi over 4 is in the first quadrant, which is the same as A, but instead we're walking -3. So I'm going to face on the same angle as pi over 4, but I'm going to walk backwards 1, 2, 3. We're now in the third quadrant. That's D. 5, 0. 0 radians, but 5 units away from the origin. 5 pi. F. G. Ooh. G is the same thing as another point. You guessed it. This is also comma G. Facing 0 degrees, but walking backwards 5 units. Essentially, these are the same. 3, 5 pi over 4. That is going to be ooh, it's the same thing as another one. You guessed it. I should use a different color. These are the same points. 5 pi over 4 is down here, but it's walking forward 3 points, 3 units. This is the same angle as 3 pi over 4, as pi over 4 and walking backwards. So again, you're rotating 5 pi over 4 counterclockwise, and then you're walking forward towards that angle. Here we rotated pi over 4, but we walked backwards. It's not a coincidence that 5 pi over 4 and pi over 4 are basically the same line. If you could see my mouse, the same line, whether we're depending on if we're walking forward or backward. 0 pi over 2. Ooh, 0 pi over 2. That's interesting. You are rotating, but you are not moving at all. So that is still the origin. In fact, I and J are the same point, essentially because both the R's are the same. So I'll use a different color. Let's go with blue. These are the same point. And essentially, let me write that better. These are all the same, all the origin. Because we could rotate as many angles as we want, but if we're not moving forward or backward away from that, we're still on the origin. So what we would have done is then explored, but this is not completely necessary for us to know, but it's interesting to see this. We would have grabbed our graphing calculators and explored what polar graphs would look like. In other words, let me change my screen share here. Where is it? There we go. New share. So this is Desmos, of course. Now, you didn't know this. Maybe you did, but if you go to graph settings there's this little button here that was there all along. That's going to change this XY coordinate into a polar graph. And you can see they have labeled 1, 2, 3, 4, 5, and they're technically all positive. But you can also see very closely there are radian measures on here. So if I make a table, oops, this is, wow, still XY. Can I change it to R theta? Yeah, it can. Okay. Instead of we're making a table of R and theta. So if if we type some of those points like 5 comma, let's go pi over 2. Wait, what? That's not 5 pi over 2. Whoa, technical difficulties. Is this treating it like whoa, that is really wrong. I'm probably not using this table function correctly. That is so not 5 pi over 2. Okay. Anyway, what we would have done is instead of using xy, we would write r equals cosine theta, which makes a weird circle, but it's a circle nonetheless. Now, there's a way that polar graphs can make flowers and stuff. Watch what happens if I put a 2 here. And I'd make the class explore and all the different things you could do. You can do some really bizarre things. I'm just going to play around with this. How about 3? How about, oh, that's 4. Here's 3. Here's 5. Here's 9. Let's see here. What about sine theta? It's another circle, but it's vertical. I'm going to put 2 here, 3 here. These are polar graphs. Typically, in the long past, we'd make students memorize how to graph these, but for this year, not so concerned. But I just wanted to show you guys this. This is pretty cool. And you can get some really bizarre things with here. I'm just going to type in 2 plus cosine theta. Whoa, look at that. We're going to zoom out a bit. That's not too exciting. Basically, kind of looks like a circle with a weird flat area here. But if we just put a number in front of this cosine, completely different. This is called a limacon. And this is called a how I forgot. Oh, I know, I remember. This is called a cardioid. If you heard the term cardioid microphone, it's because the way the sound picks up from the microphone is in the shape of a cardioid. It's not picking up noise from behind the mic. It's only specifically in front of it like this, like a cardioid. That's where that comes from. Let's go 3 and 3. It's also a cardioid. And if I put 3 cosine, 3 sine, that's also a cardioid, but it's now a vertical cardioid. You can get some really bizarre this. I've never done tan before. Tan's this weird looking thing. Now it looks like a hot dog on top of a hamburger. What about 2 tangent? I don't even know what this does. Oh, it just makes it wider. How about 2 tangent 2 theta? Wow. It's like 4 pencils. Yeah, you can get a lot of weird. There used to be a way to make a spiral. I don't even remember. Is it cosine theta? Sine theta? No, that didn't do anything. How about cosine plus sine theta? That's nothing. Anyway, that's polar graphs. You can Google this or play it around with yourself with desmos.com. Either way, this is the end of the lesson. You have one final assignment that deals with somewhat newer material, but hopefully that cleared things up in regards to polar coordinates. Very interesting topic. Otherwise, keep your hands clean and stay socially distanced. I will see y'all later.